Hi guys, and thank you for watching this. So you guys are interested in thermal modeling of the battery system, right? Of course, cooling the battery system using this ANSYS workbench. So the very basic concept is that when the heat is generated, which is passed through uh, lithium-ion battery, any lithium-ion battery, huge amount of heat is generated if the charging rate is very high. If we generate an insane amount of current, according to Joule's law, of course, there is a Bernard's rule, Bernardi's equation, which says that there are entropic heat generation as well as Joule's heat generation, and these two heat generation create this insane amount of heat in the lithium ion batteries, which ultimately will cause thermal runaway if not controlled. But this is a very rare case. uh, to predict this, we need to understand about how heat is generated in the lithium ion cell. And this project will be the basic concept, basic system to know and understand how heat is generated in the system and how can we cool the system. I have used 18650 lithium ion cell, and around the C rate of zero point 0.8, or something like that. I'll discuss it in the details in the further videos. Mm, to model the heat generation, and we'll use forced air cooling strategies to cool the air, to cool the lithium ion batteries and the whole battery module system. I have used a single cell and confined. Okay, we'll talk about the geometry later. So this is our workbench process, the workbench schematic. I've used the analysis system, geometry, picked up the geometry from here to here, and I right click into the geometry and opened this design modeler. I've used specifically that design modeler because I find it very handy to create parametric designs without too much hassle. But once you are familiar with this design modeler, it is very easy to create such designs. However, if you are not familiar, you can find other counterparts of this app, this ANSYS workbench, such as SpaceClim, to be much more user friendly. But I will suggest design modeler only because it has very smoother way of creating parametric designs. So the first part that I've created is this lithium ion cell, which is 18 diameter and 65 long. So this is 18650, and there are tabs which are metallic parts just above and below the cell, which are used to conduct electricity from the cell to the wire. Because this is used generally to prevent the huge intense thermal hotspot. Okay, so you guys know about the contact modeling. So there, if the wire and the electrode is directly joined, it will create a contact which will be extremely heated and it will create insane thermal hotspot. However, this post tab, this bus bar, this is a metallic part, also creates thermal hotspot, but this will be a little less than using directly wire to the system. So to electrically insulate this metallic part bus bar, I have used tape, polyamide tape, to electrically insulate the system, and let the system to be thermally conductive, because this polyamide tape, this Kapton tape, is thermally conductive while being insulating electrically. I've used aluminum cell, SHELL cell, or simply aluminum hollow box, to house this system into inside the hollow part, to make this a module, so that it will be protected from air and water. And I've assumed this is air dust protective, IP, ingress protected. uh, this lithium ion cell inside this aluminum box is fixed using the wooden parts, wooden structure like this. And this wooden structure is not completely filled with wood in real part. I have also done the experimentation on this system that I'll show you guys later. uh, this wood is structure to structurally support the lithium ion cell, this 1865 cell, into the aluminum box. So this is our year path, which is this is whole domain, year domain, and we have placed the lithium ion cell at some part in this domain. I've used okay, I'll create so all the bodies, and I'll show you the name selection. This is our inlet, forced air inlet, and we have used fan for this part, and this is our outlet. Okay, sorry, outlet is for this part, and this is our of course we have seen the seal and bus bars, positive tab, negative tab, aluminum housing, and wooden support, all those things. So this is how the geometry is created. So here we can generate, I'll show you guys one thing. We can generate this aluminum box, or simply aluminum cell. I have used thin feature to parametrically vary the uh, this cell thickness. This hollow cuboid box is zero point 0.8 mm thick now, but I can easily change the value from the workbench, or simply doing any kind of parametric study such as optimization and other kind of study also. So this is all about creating geometry of cell in which heat is generated and it will be cooled using air cooling technology, or simply air cooling process, or forced air cooling method. Thank you for watching, and I'll continue next part in next video.